Hi all, my name is Yannick Moy. I'm working at Educore and this is our 7th Find the Bug Challenge. This month we help kids, parents and teachers decide what to put in a kid's school backpack. This is always a source of endless discussions for parents when it should really be time to go to bed. So here is a program which does it for you. Each item which should go in the backpack has an associated utility, fun and weight. So compass, for example, will rank high on utility but low on fun, whereas the hand catapult will just have the opposite rankings. Then the job of the program is to select appropriate items in a list of belongings to put in the backpack. Of course, not everyone has the same priorities, so there are 3 possible strategies for selecting the items, depending on whether you're a kid, a parent or a teacher. Here's the code. Let's call CodePeer on that. CodePeer reports 3 medium warnings and 1 low warning. That's not so many, so we'll look at them all. The first error is about index res possibly being not in range. Res is the result of calling find more useful, and if we look at function find more useful, it indeed returns 0 if no useful item was found. Hence, the code calling find more useful should test that res is not null before accessing array B at this index. The second error complains that some other local variable named race is possibly uninitialized at the point where it is returned. Here, indeed, local variable res is only initialized in the loop if some fun item is found. Therefore, it might be uninitialized when returning. Instead, we should give it a default value of 0 from the start, which indicates precisely that no item was found. The third error is like the first one, so it's easy to correct. Now the last error is about some possible integer overflow. Indeed, summing the weights of the selecting items might well overcome the 10 kilograms limit that a variable of type weight should respect. Instead, this addition should be protected from overflowing the weight type by calling the appropriate min function. So with these corrections, let's rerun CodePeer. Great. We see that there are no more warnings. By looking at the delta columns, we see that all the previous warnings have disappeared. So that's a good sign that our patch was correct. Now, that doesn't mean our program is doing what it should. Luckily, this program is not only in Ada, but it is in a subset of Ada called Spark, for which there exist verification tools that you can use to verify almost arbitrarily complex properties. For example, I could verify that this program, once corrected, always selects the mandatory items in priority, whatever the strategy, so for example, kid, parent, teacher, is used. I say once corrected because, in fact, the current program contains a subtle bug which makes it functionally incorrect. Just to show you that you can call the Spark tools on this code, first you call the examiner, which verifies that the code is Spark indeed, and which generates logical formulas. Then you call the simplifier, which tries to automatically prove these formulas to show that the code is correct. And finally, you call this summarizer tool, which gives you the result of all this process. So for example, here, not everything was proved automatically. But that should be really the subject of a different kind of series. So now, if you're interested in knowing more about CodePeer or Spark, please visit our website on www.educore.com. Bye-bye.